Welcome to Groundzero, a unified data analytics platform that enables enterprises to make informed decisions quickly by integrating data sources and machine learning techniques in one place without compromising on security, scalability, or data integrity. In the real world, building machine learning solution involves multiple tools adding to complexity and cost. Teams prepare data in one system, train models in another, track experiments separately, and then use different tools to generate insights. This fragmented approach quickly snowballs into a governance nightmare. In this video, we will showcase how Ground Zero solves this problem and enables faster decision making. We will demonstrate by taking the universal problem of customer churn, which refers to customers who are likely to stop using a product or a service. Churn is a critical metric because it is seen that retaining customers is highly cost effective than acquiring new ones, and small improvements can significantly impact revenue. Lately, businesses have started leveraging their customer engagement data and also apply machine learning techniques to identify the at risk customers and take timely action. This process requires an end to end workflow connecting data, models, and governance in order to generate insights. We will build a churn model using Ground Zero notebooks, track and manage experiments using MLflow, and then bring the trained model into the Ground Zero designer. Finally, we will categorize customer into various risk groups and then visualize the results. Let us start by creating a connection from the Ground Zero connection page. We set up a Snowflake connection where the customer data is stored. Select Snowflake from the connection dropdown and then enter the required authentication details. Test the connection and then once it works correctly, save it. Now the connection is successfully tested. Let us go ahead and save it. Next, let us create a project and launch a new notebook. Navigate to the DEML section, which is Data Engineering and Machine Learning section. This is where we create and manage projects that contain jobs, notebooks, and machine learning models. Give the project an appropriate name and then save it. Once the project is created, we shall open it in the Notebook tab and click on New Notebook to begin. On the Notebook Setup page, select the Snowflake connection that we have created earlier. Choose a suitable runtime environment based on the task and then click on the Start Session icon. This will launch an active kernel. Once the session is ready, we can quickly explore some basic notebook functions such as adding markdown and code cells, deleting them, and then executing them. With the environment setup, we can now move on to the notebook where the churn prediction model is built and tracked using MLflow. Let us break this down into several steps. Step 1 is importing libraries and setting up the environment. We begin by importing all the required libraries for data processing, visualization, machine learning, and experiment tracking. This includes the standard Python libraries such as Pandas, NumPy, and Matplotlib for data handling and analysis, and XGBoost for building churn prediction models. We also import MLflow to track experiments, metrics, and train models, and the Groundzero SDK to connect to external data sources. Step 2 is connecting to Snowflake and loading data. Next, we connect to the Snowflake using the pre-configured Groundzero connection. Using this connection, we load the retail customer churn dataset directly into the Pandas data frame. Once the data is loaded, we perform a quick validation by checking the number of rows and the columns involved, along with its schema. Step 3 would be exploratory data analysis. Before training any model, we explore the data to understand customer behavior and churn patterns. We analyze churn distribution, age, and income differences between churn data and retained customers, their satisfaction scores, purchase behavior, and membership status. These visualizations help highlight important business insights such as higher churn among low satisfaction customers, lower tier memberships. This step ensures that the model is built on a solid understanding of the underlying data and business problem. Step 4 would be the data pre-processing pipeline. Once the data is understood, we prepare it for model training using a production-ready pre-processing pipeline. We separate the numerical and categorical features, apply scaling to the numerical columns, and then encode the categorical variables. We also engineer a new feature that captures the number of days since a customer's last purchase, which can be a strong indicator of churn. Step 5 would be to train and test models with the MLflow tracking. In this step, we train multiple machine learning models while tracking everything using MLflow. An MLflow experiment is created to compare three models: logistic regression as a baseline, random forest as a traditional machine learning approach, XGBoost as a high performance model. For each model, we log performance metrics such as AUC, along with important artifacts like feature importance files and confusion matrices. MLflow automatically captures model parameters, metrics, and trained models, allowing easier comparison across runs. At the end of this step, the best performing model is selected based on the test AUC. Here are the results for the experiments and the training. As we can see, all the three models are successfully trained with their AUC values, and the best model is being derived. Step 6 would be model registry, which is to promote the best model. Finally, the best model will be registered here in the MLflow Model Registry. Now that we have captured a high performing run, it is time to move from experimentation to governance. Let us navigate to the Models tab within our project. Here, we can see that the churn predictor model contains the container that was been created earlier. Right-click on the model in order to see the selected view in MLflow. This takes us directly to the MLflow UI. Here we can see that version 2 of the model has been automatically registered from our last run. This is an important step for reproducibility. We are not just saving a model file, but the version controls the entire model lineage. Clicking on version 2 opens the detailed view where we can inspect the model metadata. In this view, you can see that the system has automatically captured the full model schema. Under the input section, the expected fields such as age, annual income, credit score, and other features are clearly defined. This acts as a contract, ensuring that when the model is used in production, the required data format is well understood. Since we train multiple models, let us also switch to Experiments tab to open the retail churn prediction experiment. We select the three models that we've run: the XGBoost classifier, the random forest model, and the baseline logistic regression model. After selecting all the three, we compare them and view them side by side. The comparison dashboard also makes it easier to evaluate performance. With our best model identified, the next step is to make predictions useful for business. A raw churn probability alone is not always actionable. So, we next move to the Designer tab where we can translate these scores into meaningful business insights. We begin by creating a new dataset and giving it a descriptive name. This dataset will be used to apply our train churned model to customer data. Next, we bring in the input data. We select the existing AWS S3 connection to load another retail dataset directly to the environment. Once the dataset is loaded, we select the appropriate runtime environment for the execution. From the left pane, we then choose the registered churn model from the models dropdown. This makes the model available within the dataset workflow, allowing us to generate churn predictions on this new data. We start by loading a fresh retail dataset from the existing S3 connection using the Groundzero client. This file is downloadable and then read into a data frame. You can normalize the column's name to uppercase to avoid schema mismatches. Then we use feature engineering for scoring in order to check if the data stays consistent with what the model has learned. Then we wrote the registered model, use aligning data to the model schema, run model predictions, and then classify them into risk zones. Then we aggregated as results for visualization. The last block of code prepares output DF, which is optimized for charting. Let us save and hit run to execute this logic. This is our result. We have predicted scores and categories for each customer. Now, let us run this dataset again with having our output DF grouped for the aggregates of each risk zone. Here we have a clean summary table. We can see that bulk of our user base is stable. But more importantly, approximately around 7K customers in the critical bucket. That is the number our business teams need to care about. Finally, let's bring this data to life. We will be creating a bar chart as it is the most effective choice with the dataset that we have just engineered. Now the configuration is simple. We'll map the column value to axis once. On the vertical axis, we want our categories. And on the series value, let us have the customer count. The chart renders instantly, and let us now quickly customize the chart. Now, we have a clear, immediate visual representation of our risk profile where we can see the distribution from stable to critical. The interactivity is the key here. We can hover over the bars to see the exact count of the customers of each risk zone. This visualization is not just a static chart, this is directly connected to the live data and corresponding machine learning workflow. What makes this powerful is the complete MLOps lifecycle behind it. The model is trained, tracked, and compared with the version of MLflow, ensuring full reproducibility and governance in real time. Groundzero enables a complete end-to-end implementation of the entire ML lifecycle, from raw data and notebook-based experimentation to a production-ready, business-facing outcome. This helps teams move faster and make better decisions. Thank you.